Hey students, on this clip we're going to be reviewing some concepts on angle. Alright, let's go ahead and take a look at the instructions for the first two problems. Let's see. So, express the given angles in degrees and radians. Graph the angle. State the quadrant. And find the reference angle expressing it in degrees and radians. Alright, so let's take a look at the first question. Question number 1. We're going to look at theta equals 7 pi over 12. 7 pi over 12 radians. Okay, so this given angle is expressed in radians, so we are supposed to convert it to degrees. So in degrees, what is 7 pi over 12 in degrees? So 7 pi over 12 in degrees, we're going to multiply it by the conversion factor. Okay, we have two choices, either pi over 180 over 180 degrees, pi over 180 degrees, or 180 degrees over pi. Okay, so which one are we going to use? Since there's a pi upstairs here, we're going to use the one with the pi downstairs so the pi's cancel out. So I'm going to multiply by 180 over pi. Okay, all right, notice that these pi's divide out. Pi goes here 1, pi goes here 1. 12 goes into self once. 12 goes into 180 15 times. 7 times 15 is 105 degrees. All right, so theta equals 7 pi over 12 or 105 degrees. All right, so there goes our first answer, expressing the angle in degree and radian form. Next, we're going to go ahead and graph 105 degrees. So this is a positive angle, so we're going to be going in a counterclockwise rotation. Okay, so now, there goes our coordinate system. We're going to start from 0. Remember, when it's positive, you go up and around counterclockwise. And when it's negative, you go clockwise, down and around. Alright, so now every quarter of a circle is 90 degrees, so we're going to keep going until we find two quadrants that, two axes that bound this number. Okay, so 0 is too small, keep going 90 degrees, too small, keep going 180, too big, so it has to be somewhere here. Alright, so our terminal side is going to be located in this quadrant. Alright, so let's indicate the area swept by the angle from the start to the terminal side. So from here to here, that is 105 degrees or 7 pi over 12. Now, this is going to be, what quadrant is it in? It's clearly in quadrant 2. So we're in quadrant 2 here. Quadrant 2. So this is 1, 2, 3, 4. Alright, now next thing we have to find is the reference angle. The reference angle is the angular measure from the terminal side to the closest x-axis. This is the closest x-axis right here, so this represents our reference angle. Okay, I'm going to call this theta reference. Alright, how do we find the reference angle? We just find the angular separation between 180 and 105. Alright, so let's write this down, reference angle. Our reference angle theta ref is going to be 180 degrees minus 105 degrees. Okay, so that's simply going to be 75 degrees. All right, 75 degrees. 75 degrees is our reference angle in degree form. So we need to find our reference angle in radians too, because it has to be expressed in the two forms. All right, so theta reference in radians is going to be 75 degrees times the conversion factor. The conversion factor is going to be, since there's a degree here, we're going to use 180 over pi. Okay, so there goes your reference angle. All right, so what we're going to do now is we're going to divide by 15. So reduce by dividing by 15. So 15 goes here 3 times. Um, 15 goes here, see. Actually, it goes here 5 times. 15 goes here 5 times. And 15 goes here 12 times. Okay? So multiplying across, our theta reference is going to be 5 pi over 12. Alright, so theta, the reference angle expressed in radian form, in degree form, is going to be 75 degrees, or 5 pi over 12 radians. So there you have it. Okay, now for number 2, we're going to be doing the same procedure, but our problem will be given to us in degree form, okay? So for number 2, we have 200, actually negative 200 degrees. Alright, so theta is negative 200 degrees. I'll write that properly again. So if theta is negative 200 degrees, we're going to express it in degree and radian form. Alright, it's already in degree form, so let's go ahead and express it in radians. So how do you express this in radians? So in radians, we're going to multiply negative 200 by a conversion factor. So we have negative 200 degrees. Now we're going to multiply it by, since there's a degree on top, I'll put 180 degrees on the bottom and pi on the top. Alright, so the degrees cancel out. We can also divide the zeros. Okay, and now we have negative 20 pi over 18. This can be reduced further. 2 goes into 20 and 18, so if I divide the top and bottom by 2, divide by 2, divide by 2, I'll end up with negative 10 pi over 9 radians. Alright, so theta in radian form, so theta is going to basically be negative 200 degrees or negative 10 pi over 9. Alright, now what we're going to do next is sketch the graph of our angle. Okay, so where is negative 200 degrees or negative 10 pi over 9 radians? Now let's create our coordinate system. Now, since our angular measure is negative, we're going to be going in the counterclockwise, the clockwise rotational direction. Okay, so let's see. This is 0. Now we're looking for negative 200, right? So we're going to go down. Remember, down and around is negative. This is negative 90. Keep on going, negative 180. Too small, keep going, negative 270. Too big, we need to back up. It's going to be somewhere here in quadrant 2, just like the other one. So negative 200 is right here. Now let's indicate the region swept to generate our terminal side. So the region that was swept is, we started from here, went clockwise and rotated all the way there, down. Alright, so this right here is negative 200 degrees. Now, what we need to find is a quadrant. What quadrant is this? This is quadrant 2. Now, what is the terminal side? What is the reference angle? Reference angle is the angular measure from the terminal side to the closest x-axis. So this is equals as x and negative x. So this right here is your terminal, is your reference angle. So what is the value of our theta reference here? All right, let's go ahead and find it. It gives us the next result. So reference angle. So the reference angle is going to be the angular separation between 200 and 180. Remember, a reference angle is always positive, right? So we're going to ignore the negative signs here and just focus on the magnitude of the number. So theta reference, I'm going to write it as theta ref equals the bigger minus the smaller 200 minus 180, and that's going to be 20 degrees. All right, so that's the degree form of our reference angle. In our radians, it's going to be 20 degrees multiplied by the conversion factor. Since there's a degree upstairs, we have a degree on the downstairs, 180 high. All right, so the degrees cancel out, the zeros cancel out, and 2 we can reduce by 2, right? 2 goes here 1, 2 goes here 9. So our reference angle in radians is going to be pi over 9. So theta reference is pi over 9 radians. So there you have it. Okay, so let's pi over 9 radians or 20 degrees. There goes our second result. Okay, so that's that for angle conversion and graphing and also reference angle. Now let's move on to the use of the unit circle. All right, so instructions for question 3 and 4. We're going to find the exact value of all 6 trig ratios of the given angles using the unit circle. Okay, using the unit circle. All right, so number 3, let's say theta equals 330 degrees. All right, so first thing we're going to do is locate 330 degrees on a unit circle. We can clearly see that it's located right here. So all I need is the coordinates that correspond to that angular measure, which is √3/2 and -1/2. All right, so 330 degrees is going to give us √3/2 and -1/2. Now this is my x coordinate and this is my y coordinate. So now we have to figure out all 6. Okay, so we're going to use the unit circle ratios. It's on your formula sheet. On the upper corner right here, you have your unit circle ratios. So let's start out with the first one, which is sine. Sine of 330 degrees. Sine is usually the y coordinate. Okay, so sine 330 is -1/2. To find the reciprocal of sine, which is cosecant 330, to find that, that's simply 1/y, or we can just reciprocate -1/2. If we reciprocate -1/2, we have -2/1, which is just -2. Next, we have cosine 330. The cosine is the x-coordinate. The x-coordinate here we can close is √3/2. So there goes your cosine. The secant of the same angle is a reciprocal, 1/x. Or we can just reciprocate this, is going to be 2/√3. Now let's rationalize the denominator. √3, and multiply across. We have 2√3/3. And there goes your secant. Next thing we need to find is tan. Tan of 330 is y/x. Since y and x is about fractions, I'll write my fractions or my division of the two fractions horizontally. So y divided by x. Okay? Now, when I'm dividing fractions, I'll multiply the first by the reciprocal of the second. So I'll drop this one, negative 1/2, change this to times, and then I'll flip this, okay? Because division is the same thing as multiplying by the reciprocal. Now the 2's divide out, 2 goes here 1, 2 goes here 1, multiply across, you have negative 1 over root 3, and then you rationalize the denominator, root 3, and that's going to give us negative root 3 over 3 for tangent, alright? Now cot 330 is x over y, or we can just simply reciprocate this number right here. So let's go ahead and do the reciprocation. If I reciprocate this, I'm going to have negative 3 over root 3. Okay? Since we can have a radical in the denominator, multiply root 3 top and bottom. And that yields negative 3 root 3 over root 3 times root 3 is 3. And then just divide these 3's out. And final answer will be negative root 3. Alright, so there goes your 6 trig ratios. Let's write them in an organized list. Sine 330 is negative 1/2. It's reciprocal. Cosecant 330 as negative 2. Cosine 330 is root 3 over 2. Secant 330 is 2 root 3 over 3. Tan 330 is negative root 3 over 3. And cot 330 is negative root 3. Alright? So that goes all your 6 trig ratios. Alright, that's that. Let's go ahead and try out number 4. For question 4, we have theta equals negative pi over 4. Okay? Alright, so note that this is a negative angle we're dealing with here, so there has to be some reflection going on, or opposite rotation. Okay? So let's look for pi over 4. This is pi over 4. Since we're looking for negative pi over 4, we're going to have to reflect up or down. Okay? Since we're upstairs, and this is the point that corresponds to pi over 4, we need to reflect straight down, and that is going to be negative pi over 4 right there. Okay? So this point right here, negative 7 pi over 4 is what negative pi over 4 is. Alright, so negative pi over 4 is going to be the coordinate of 7 pi over 4. And then we're going to be using roots 2 over 2, comma negative root 2 over 2, okay? Now let's, this is the x coordinate, this is your y coordinate. So let's find all 6 trig ratios. Sine of negative pi over 4, using your unit circle ratios is the y coordinate. The y coordinate here is negative roots 2 over 2. Okay? Now next thing we need is the cosecant. Cosecant of negative pi over 4 is 1 over y, or we can just reciprocate this, which is negative 2 over root 2. Rationalize the denominator, root 2, top and bottom, and that yields negative 2 root 2 over 2. Alright, so these can also divide out. 2 goes here 1, 2 goes here 1. You have negative root 2 for your cosecant negative pi over 4. Now cosine. Cosine of negative pi over 4 is your x coordinate. And your x coordinate is root 2 over 2. Now secant of negative pi over 4 as the reciprocal of the x, which is 1 over x, and that's 2 over root 2. And then rationalize the denominator, root 2, and that's basically going to be 2 root 2 over 2. So divide out, final answer is root 2. Okay? Now tan of pi over 4, actually tan of negative pi over 4 is y over x. So y is negative root 2 over 2 divided by x, which is root 2 over 2. So you drop, change, flip, multiply the first by the reciprocal of the second, like that. And then we can reduce. 2 goes here, 1. 2 goes here, 1. Root 2 goes here, 1. Root 2 goes here, 1. Final answer is negative 1. Alright? Now your cotangent of negative pi over 4 is x over y, or the reciprocal of the answer we just got. The answer we just got is negative 1. If I reciprocate that, I'll have negative 1 over 1, which is still negative 1. Alright? So there goes our 6 trig ratios. Let's organize them on the right here. Sine of negative pi over 4 equals negative root 2 over 2. Cosecant of negative pi over 4 equals negative root 2. Cosine of negative pi over 4 equals root 2 over 2. Secant of negative pi over 4 equals root 2. Tan of negative pi over 4 is negative 1. And cotangent of negative pi over 4 is negative 1 also. Okay? So there goes all your 6 trig ratios. Alright, now let's move ahead to review on the quadratic formula. Alright, so question number 5 and 6, solve the given quadratic equation. Solve the given quadratic equations. Alright, so problem number 5. Let's say we have the quadratic 3x squared plus 6x equals negative 10. Now let's put this in standard form. Basically set equal to 0 with each term in descending order. I mean each term with the degrees in descending order. Alright, so this 10 has to move to the left, so it's equal to 0. So to accomplish that, we'll do the opposite, namely add 10 to both sides. Okay, so that gives us 3x squared plus 6x plus 10 equals 0. Okay, so now we can try and factor this using the x scheme. Let's see if we can be successful. You make your x. AC goes on top. AC is 30. B goes on the bottom. 6. Alright, let's see the combination of numbers that yield 30 and see if any of these can give us 6, okay? So for 30, we have 1 times 30. That doesn't work. 2 times 15 gives us 17 or 13. That doesn't work either. Let me draw this line properly. And then let's try another combination. How about we try 3 and 10? 3 and 10 gives us 13 or 7. That doesn't work. Last one is 5 and 6. 5 and 6 doesn't work either because this gives 11 or 1. So this is a prime quadratic. It cannot be factored. So we have to use the quadratic formula. Okay, so A is 3, B is 6, and C is 10. We're going to use x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so this is what we're going to be using here. Alright, so let's go ahead and apply this quadratic formula to this problem. So we have x equals negative 6 plus or minus the square root of 6 squared minus 4 times a times c, and then the whole thing divided by 2a, 2 times 3. Alright, let's go ahead and work this out. We're going to have negative 6 plus or minus the square root of 6 squared is 36. 4 times 3 is 12, times 10 is 120. Minus 120 over 2a6. Okay? Alright, let's simplify further. we're going to have, this is going to become negative 6 plus or minus the square root of negative 84 divided by 6. Okay, and let's simplify further. We're going to have x equals, well, let's reduce the square root of negative 84. Okay, let's see what that gives us. So let me write the problem here. Negative 6 plus or minus root negative 84 over 6. Now to the side, square root of negative 84. This negative comes out of the square root as an I. Okay, because the square root of negative 1 is I. Now let's reduce this. I can take out 2 since it's even. 2 times 42. Take out another 2. 2 times 21. Take out 3. 3 times 7. So since these two 2's repeat, they can break out as a 2. Okay? So this becomes 2I root 21 as the reduced form of this. So x is going to become negative 6 plus or minus 2I root 21 divided by 6. Okay, I can split this up for ease with reduction. So I'll have negative 6 over 6 plus or minus 2I root 21 over 6. Okay, and dividing further, we're going to have negative 1 plus or minus I root 21 over 3. If I divide this by 2 top and bottom, I get this. Okay, so let's split our answers out. Our answers are going to be minus 1 minus I root 21 over 3 and 1 plus I root 21 over 3. Alright, so there goes your answers. Alright, let's move on to the last question. Question number 6. We're going to solve another quadratic equation. So for question number 6, we have 6x squared equals 13x minus 7. Now for this one, we need to put it in standard form first, and set it equal to 0 with the degrees in descending order. Alright, so to do that, I like to have my first term positive, so I'll move these 2 to the left. So subtract 3x and add 7. Subtract, 13x and add 7. So that's going to give us 6x squared minus 13x plus 7 equals 0. Alright. Okay, now let's go ahead and see if we can factor this. If we can't, well, you have to use a quadratic formula. So we'll make our x, okay? And while I'm at it, I'm going to make myself a nice t-chart over here to exhaust my products that could possibly yield the v. Okay, so now AC, remember this is ABC. AC is 6 times 7, which is 42, and B is negative 13. Alright, so what number is multiplied to give us 42? So we have 1 times 42, that doesn't work, gives me 43 or 41. 2 times 21 gives me 23 or 19, that doesn't work. 3 goes here 1 time, 3 and 14. This doesn't work, this gives me 17 or 11. Let's try 6 times 7. 6 times 7 works because 6 plus 7 is 13. Alright, so let's use 6 and 7. What works here? They both have to be negative. Like that. Okay, good. So we're going to have 6x squared minus 6x minus 7x plus 7 equals 0. Going to break it down to center and factor by grouping. Okay, so let's see how we're going to do this. Break everything down completely. So we're going to have 2 times 3 times x minus 2 times 3 times x minus 7 times x plus 7 equals 0. From the first two, I can take out 2, 3, and an x. So 2, 3, and x. That's 6x. Pull that out. I'm left with x minus 1. And on this side here, I'm going to take out a negative 7 from both sides. When I take out a negative 7, I'm left with x. And since I'm factoring out a minus from the plus, it becomes a minus 1 equals 0. Okay? Now this looks good because the two quantities in the parentheses are the same. So this and this I will factor out to x minus 1. And the numbers on the outside, 6x and negative 7, I'll put them together in the parentheses. 6x minus 7 equals 0. Okay? Now what I'm going to do is set each factor to 0 using the process called the zero product property to finish this problem off. So x minus 1 equals 0, 6x minus 7 equals 0. Alright, so for the first one, add 1 to both sides. You have x equals 1. And in this one, you add 7. And then you have 6x equals 7. And divide both sides by 6. You have x equals 7 over 6. Right? So your final answer is going to be, or your answers are going to be 1 and 7 over 6. Alright, so there you have it.